Three things today. We're to find instantaneous rate of change and average rate of change. Then we're also going to learn what the mean value theorem is and be able to apply it. So those are what we're looking at today. So let's start with instantaneous rate of change. It is also, or will be, talked about in here as IROC. So when I say IROC, you know what I'm talking about. I do rock though.
Whenever we say it, is it you rock?
Still IROC.
So you
So we say IROC and we know which I was talking about.
Yes, that's right. All right, so instantaneous rate of change. What do you think? And Sam, you can't answer every question today. You've already been in there. But what do you think we're talking about with instantaneous rate of change?
How fast is changing at an instant?
That is correct. So how fast my function is changing at an instant. Very good, Harrison. And how do we find that, Harrison?
I guess you're gonna give us a way.
No, you're going to tell me how. How do I tell how fast?
the derivative?
Say it again.
Find the derivative.
Find the derivative and do what?
Plug in.
Plug in.
Plug in something.
That's how you find instantaneous rate of change. Is find the derivative and plug in the x
You
value.
find everything backwards.
Okay, what does that represent?
The instantaneous rate of change.
Of
The derivative. The
Of
original.
that point.
The original. The second derivative.
what slope do we get from the derivative?
Tangent line.
Tangent line. So instantaneous rate of change is the same thing as the slope of the tangent line at a particular x value. That's what instantaneous rate of change is. It's how fast am I changing at an instant,
Wait, then what's changing?
the function.
Like deer.
You can tell it's changing by the tangent.
Is it gonna be like water and a guy fishing and stuff?
I'm so confused.
We will have a car problem.
Oh, no.
So will these problems be kind of like the related rates
Why would
things?
you say
No.
Okay.
Good.
Awesome.
The answer states
Thank you.
Alright, that's instantaneous rate of change. What do you think about average rate of change though?
Over the whole interval.
An average rate of change must take place over a closed interval. That is correct.
What's the acronym for that?
The acronym for that is AROC. So the average rate of change is AROC. Alright. Now let's talk about it. You should have heard the word average earlier this year.
Yeah.
When?
Well, we're doing related rates. Or not really.
Position, velocity,
Position.
Position, velocity, acceleration. So if I wanted average velocity, how did we find average velocity?
Change in
The one
time
above
over
it, the
change
one
in
before it.
speed.
The one before it.
Change in
Change in the
Time.
function above over the change in time. So if I want average of something, it was always the change in the function above over the change in time.
So are we
He's
going
about
This is
to,
where
he was
it
about
gets
to.
If I want average velocity,
This
it's
is where it
change
gets
in the function above.
So we're
If
going
I want
back
average
up.
acceleration, it's the change in the function above.
But that's not the case.
So average velocity is the change in
I'm
the
just reminded you to confuse.
Okay. Now, there are two key words on average rate of change, and that is
Average
of change.
Of is a
When you-
keyword.
Yes, it is. That tells you when to do something versus something else. Okay. Now, on the averages we've done so far, it's always been the change in the function above over the change in time. Okay. But when you hear average, when you hear of change, we want the change in the function we're talking about. So if I want the average rate of change of f of x, I want the change in f of x. Okay? But if I hear average velocity, I want the change in I don't want to change the velocity, I want to change the position. Okay? So when you hear the word of change, what does that tell you want the change in?
The one.
What you're dealing with.
The function I'm dealing with. That is why it's so important to recognize when you see of change. Because of change wants the change in the function you're dealing with. If you do not hear the word of change, what does it want to change in?
Whatever it says.
The function above. That is extremely key. If you take away one thing today, that's the one thing you need to take away. Is when you hear of change, you want the change in the function you're dealing with. If you don't hear of change, you want the change in the function above. Everybody hear me?
Yes.
Okay? So if let's reterm something and see if you can figure out the difference. If I want the average rate of change of velocity, what am I going to do?
Change
Visual
I want the change in velocity over change in time, because what two words did we add? We did have change. But if I want average velocity, what do I want? I want the change in position over the change in time. So that's why I say that of change is very important. You've got to be able to identify of change. Okay? Now,
It's gotta be-
when we were finding average velocity or average acceleration, how did we do that? How did we find the change?
Y2 minus Y1.
There you go. Okay, over.
X2 minus X1.
Now, when you hear average rate of change, what I want you to think of is f of b minus f of a over b minus a.
Is that the same for IROC or just?
No. What is IROC?
You find the derivative. and
Remember, IROC is just the derivative and plug it in your x value.
Can't take it easy.
Okay?
plug in.
AROC is this, and we're dealing with the interval from A to B.
I feel like we're not gonna just have a thing and be able to plug the A and B in. What? Is it?
Because it's
It's
never
never
that
that
simple.
simple.
Ever.
is.
No, it's
No.
never been that simple. It's simple for like
We
the
have to
first
find-
problem.
Do we have to find A from B
Or
or
it's simple on
something?
the words.
No. They're going to give you A and B.
And the function?
Yes.
Every time?
Jimmy caught a fish. Was
If they want you to find average rate of change, they've got to give you the endpoints. Alright, so everybody good on IROC? What is IROC?
Find the
Instantaneous
derivative.
rate of
Derivative
change.
and plug in. AROC?
F of b minus f of a over b minus.
Correct. And the keywords are
Change.
of change. Okay?
Wait,
So-
are those key no change? Or not no change, but IROC?
No. IROC, you find the derivative, plug in.
Do you plug the derivative into the original IROC? Or you just find the derivative?
Find the derivative and plug in.
Plug into
Because what is it? What is it I'm finding on IROC?
The slope of the
Slope of the tangent line. So get the slope of the tangent line, you plug in. Okay? And we're getting ready to talk about what the f of b minus f of a over b minus a represent. Okay? But the keywords on that are of change. We want the change in the function we're dealing with. So, Janine, if I ask for average acceleration, what would I do?
Use the function above.
I use the function above. If I wanted the average rate of change of acceleration, I'd use acceleration. Excellent. Outstanding. So let's look at a graph and see what it is we're talking about. And that stinks that it was up there, but anyway. All right, we'll use different ones. All right, so let's say all of these are just x values. What are you saying, Harrison?
You said you're a terrible teacher and has no respect for authority.
Alright, so let's say I want the average rate of change from C to F. I want the average rate of change from C to F. And let's say this function is called, since I got F in there, let's call this function h of x. What am I going to do to be able to find the average rate of change of h?
Of F minus H of C over F minus C.
Very good. It would be h of f minus h of c over f minus c. Any questions on what we did right there? Good to go with that. Okay? Now,
prime.
Say it again. I wanted the average rate of
We
change.
don't ever have to take the derivative.
I only take the derivative if I'm dealing with IROC.
You don't even need that graph.
Okay?
You have
So, what is it? Let's go back to IROC. What do we say IROC represented?
It's
Slope of the tangent line. What does AROC represent?
Average acceleration or rate of change.
We're going with
That's what it
secants
says.
on this one.
You getting some help back there?
No. Yeah, actually I am.
This right here. AROC is the slope of the secant line. It's the line that is connecting your two endpoints. Okay, so my two endpoints, where we're going from C to F. So my two endpoints are right there. So when I work this out, when I work AROC out, I'm getting the slope of this secant line. Okay? That's the slope of the secant line. Now, if I wanted IROC, for instance, I wanted the instantaneous rate of change of H at E, what would I do to find the instantaneous rate of change of H at E?
Of E,
Say it again.
find the derivative.
Find the derivative and
Plug in.
plug in E. So IROC would have, in this case, if I wanted it at E, would be H prime of E. So that's the difference between AROC and IROC. Yes.
Will we be encountering numbers or just letters?
Yes, we're gonna do numbers.
Okay.
Is there a B
Okay,
rock?
I'm just trying to get you to visualize what's going on.
H1 and B is kind of.
Okay. Now, what would this H prime of V represent?
Basic rate
The
of
slope
change.
of this brook.
The slope at that point, the slope of what?
Tangent.
The slope of the tangent line. So what does it look like the slope of the tangent line right there should be?
0.
Should be
Go for it.
horizontal. Okay? So my AROC has this slope, my IROC at this point would have that slope. So that's the difference between AROC and IROC. Everybody clear on AROC and IROC?
Yes, sir.
Alright, now let's get to the MVT.
What?
We're supposed to just know what that means.
The MVT is the mean value theorem.
This is what
The
gets
mean
hard.
value theorem?
The mean value theorem.
The bean.
It's where we're going to
MVT.
it's where we're going to connect the AROC and the IROC. Alright. There are two what's the word? Prerequisites for the mean value theorem to work. First thing is my function must be continuous on my closed interval. We're just going to use A and B.
Or else you can't use the theorem?
You cannot use the theorem. You can only use the theorem if you're continuous. And the other one is if I am differentiable from A to B.
Shoot. What's differentiable?
What's differentiable?
I forgot how to do this.
The limit exists and the function. The limit and the function are equal. Is that what it is?
That's continuous.
The limit
Yeah.
must be continuous and the limit must exist.
That's still continuous.
Alright.
The
The
derivative
function.
of the thing must
Well,
exist?
Well, that's pretty much what it is. Can you find the derivative between A and B? Okay?
So
But the
can you find the
technical way to do it is the limit of the derivative from the left must equal the limit of the derivative from the right. That's the technicality.
That's what I meant.
When can you
Yes,
not
that's the
find a
differential.
derivative?
Say it again.
When can you not find a derivative?
Great question. So graphically, what will it look like graphically if it's not differentiable?
Short term.
Sharp turn. Jump.
Asymptote?
What type of that? No, not an asymptote.
Vertical.
Not an asymptote?
Vertical
A whole.
tangent line. Okay. What you guys are talking about is where it's not continuous.
Okay.
Okay. So where I'm not continuous, I'm obviously not differentiable.
What was the second one?
Sharp turn and vertical
Tangent.
tangent line.
So where are you not
Vertical.
continuous at?
Not continuous. Where am I not continuous at?
It's a
Holes.
Where it's not differential.
Asymptotes.
What is a vertical?
And what?
Jumps.
Oh, those are for continuous.
What does vertical tangent line do that makes it not differentiable?
That makes the derivative undefined. Because in order to have a vertical line, your slope is undefined. And if my slope is undefined, that means the derivative is undefined.
Negative 0. No. Got it?
Alright, so those are restrictions. Here's what the mean value theorem says. Alright, now read that, take it in, and I want somebody to explain to me what that is telling me. Read it, digest it, and then interpret it for me.
AROC.
Keep going.
AROC equals
derivative.
IROC.
AROC equals IROC.
Whenever AROC equals IROC, it's point C.
When IROC is in a rock interval.
No, you're close.
When
When
AROC
AROC is an
Equals
IROC.
IROC
When
somewhere at some x value between A and B. Okay? So it tells me that my average rate of change must equal some instantaneous rate of change at an x value of C that is between A and B.
This is the mean value theorem.
That's the mean value theorem.
Is
So the
is that
average rate of change must equal the instantaneous rate of change at some x value on my interval. That is the mean value theorem.
Average acceleration.
I hate
Say it again?
That doesn't rule doesn't apply to average acceleration.
No, because average acceleration isn't
doesn't understand.
an average rate. It's not AROC.
Okay, so
It doesn't work
AROC
with any other
equals
averages.
IROC.
AROC and IROC is what I worked with. If you're not finding an AROC or an IROC, it's not going to work.
At a specific X value.
So let's go back to our graph and we'll put it all together. So we were on the interval, what was our interval? C to F? So C to F, if I connect these two, what does that represent?
IROC.
That represents the slope of AROC. Okay, when I'm connecting two different points right here, this represents, the slope of that represents the average rate of change.
It's just an accident that connects with every point.
Okay, so what does, and I think you'll agree with me, from C to F, do you agree that that function is continuous?
Yes.
Yes, because there's no holes, there's no jumps, there's no asymptotes.
Or shit.
Okay, what about differentiable? Would you agree that it's differentiable?
Maybe.
Yes.
Yes, why?
Because you can find
Continuous.
continuous.
There's no sharp turns and
No
vertical
vertical
lines.
no vertical tangent lines. So
What
there's
does a
no sharp
vertical
turns or
tangent line
vertical.
look like?
It would be if I had
This could-
something that looks like that, and then I'd have a vertical tangent line there.
Okay.
So that means this thing is continuous and it's differentiable. So what does that mean? What does the mean value theorem tell me has to happen somewhere in between C and F?
It has to be an IROC.
There has to be an IROC. And how do we graphically represent an IROC?
A point.
Wait.
What type of slope? A
Tangent.
tangent line slope. So it tells me, the mean value theorem tells me that somewhere between C and F, I've got to have a tangent slope that's what?
Equal to
Equal
AROC.
to.
Equal to AROC. So what does that mean it will graphically look like, the
That
tangent
means
line?
so.
It will be parallel. So can somebody come up here between C and F and draw a tangent line that is parallel to my AROC? Somebody come do it for me, please.
Oh my gosh.
G.
no.
No.
Okay, wait.
It's fine.
E has two.
Come do it. Let's go.
Draw.
Pauline.
Yay,
Kids should
Colin.
read it.
It's not funny.
That's not
Believe
funny.
that? It's her birthday. Come on.
Happy birthday. That's
I'll
not-
take it. It's not very pretty, but I'll take it.
Roshan really tried like
Yes, Roshan, you were better than Roshan. Alright.
Oh, that's so.
That was
Bottom makes sense.
So,
Because he rocks.
so let's say at this point right here, let's see, I've used A, B, C, D, E, and F. We called it H. Let's say Q. Let's call it J.
Why don't we skip on it?
Cause I like it. But I rock.
So, can somebody come up here and write down what the mean value theorem tells me? Right here.
Point J.
I want somebody to come up and write it.
Oh.
Okay.
Okay.
Point J.
And we're calling that function H.
Not that. I'll just.
No, we're calling the function
See
H.
right now.
So use H instead of F.
Stop it. Well, me personally,
No, it's like very nice. Outstanding. That's what the mean value theorem says. The mean value theorem says that this right here is AROC, and this is IROC, and they have to, if this thing is continuous and it's differentiable, that there has to be at some point between C and F where there's an IROC that equals an AROC. Now, does anybody see another IROC that will work?
So when do we use this?
We'll get there.
Does
We've
it
got
have
to be able to
between
do
C
it
and
first.
I've got
Say it
I
again.
can see you.
It has to be between C and
It
F.
has to be between C and F. Can somebody come draw another?
Between C and F,
Ben,
another
come
one.
draw.
That's fine.
It's the only point where you can see definitely the
That'll work. Very good.
That's a solid line.
That means this right here also equals H prime of E. So notice this time how many C values between C and F were there? There were 2. What does the mean value theorem guarantee?
It was one.
That there's at least 1. So there can be more than 1, but the mean value theorem guarantees at least
Okay.
1.
Question.
Yes.
How do you do this if they don't give you a graph?
We'll get there.
No,
Okay.
that's not good.
Now let me give you the real world example. I drew a great graph flash hour.
Some
So
numbers.
A real world example?
a real world example. So I did a great graph the first hour. So let's see if I can do it again.
Is this like a real world example, or is this like if you had me looking at a graph and your teacher asks you to IROC an angle?
What is this?
We'll change it up.
It's like a
Not
It's a
We're
row.
doing stock prices.
Car.
All right. So this is the position function for a car that is being driven. Okay. Can you buy that? This is a position function for a car that is being driven. How long was it driven?
3
yeah.
hours.
3 hours. How far did it go?
180 miles.
180 miles. All right. So, what is the average rate of change of this car?
60.
60. How did you get that?
180 divided by 3.
Well, I mean,
Well, remember, if I'm going to find average rate of change, what should be coming to mind as soon as you hear average rate of change?
AROC.
No,
Yeah,
that
um,
function.
So you have miles per hour.
Oh yeah, that.
I don't know
So
what person.
so F of 3 minus.
F of B minus F of A would be minus A, so I need F of 3. And what is F of 3? 180. I need F of 0,
Wait,
which is 0 over 3 minus 0, so we end up with 60
Okay,
miles
I get
per hour.
So point A is
So
your
this is,
excess.
yes, there's 0, there's 3. So my interval is,
Yeah.
my interval is 0 to
Okay,
3.
so you didn't give us.
is F of A.
Why are we doing
F of A is 0.
B is 180
If they don't give you F of A,
like that's the point where it's at
No,
across.
they'll give you a way to find F of A.
So A is 0 because that's where it started.
It's just
Yeah.
an easy example to feel
Because that's where it ended up.
So, what can I do to graphically represent AROC?
Draw that graph.
You have F of 3 minus, like you have that thing right there.
What did we do earlier when we graphed an AROC? Draw a line between that connects what?
2 points.
Your endpoint. So we're draw a line that connects these two things. I want a different color. So that right there, the slope of that right there would be what?
AROC.
The slope of that would be AROC, and in this case it ends up being 60. Now, what does the mean value theorem guarantee?
There's at least one point where it
1
crosses.
point.
There's at least one point in there where the tangent line is parallel. There's at least one point in there where the tangent line is parallel. So, looks like right in here, somewhere in here,
There's
One
I would have
section,
that.
and then the other little above, and then
and it looks like there's one here,
There's 5.
one there,
5.
one there, and
Ooh,
one there.
man.
That's
There's
too
so
many.
many.
So, what does that tell me? What does that tell me about my car during those 3 hours?
And there's at
Sometimes it
least
was
5.
60 miles an hour.
At 1, 2, 3, 4, 5 times along that drive, I was actually going 60 miles an hour.
So the
Okay? All the other times I was doing what or what? Faster or slower. Okay? So let's take an example. Let's say at this point right here, was I going faster or slower than 60? I was going slower.
How do we know that?
How do we know that?
Because it's concave down.
If I draw my tangent line at this point, it would be like that.
So it's
Is the slope of this tangent line bigger or smaller than the slope of my 60 mile an hour tangent line? It's that slope, if it's flatter, that means it's smaller.
Oh.
So my flatter slope means that I'm going slower. Okay, when I get over here, right here, I'm going to have a tangent line that looks like that. That tangent line is steeper. If it's steeper, that means I'm going faster. Okay, so that's what the mean value theorem says. If I'm continuous and undifferentiable, and I can find the average rate of change, then it's somewhere in my interval. What has to happen?
has to be parallel. The
Slope of the tangent line.
tangent, yeah.
AROC.
Right, my instantaneous rate of change has to be the same as my average rate of change. Okay? Now, let's do this with some numbers. So, on your sheet that you don't have yet,
Can we have that?
Coach White, correct?
There's not a star.
It's gonna be tough. They keep going.
alright, we're gonna do number 9 together. And we should be able to get it in before the bell rings. So, number 9, it says f of x equals x to the 4th minus 8x. And our interval is 0 to 2.
This is number 9.
So it says determine if the MVT, if you guys need to go. Determine if the MVT can be applied.
Go.
So, can the MVT be applied?
Yes.
What do I have to ask myself?
Is it continuous?
Is it continuous? So is this thing continuous?
Yes.
Yes. What would I be looking for to make it that it would be not?
Zero in the
Zero in the
denominator.
Zero in the denominator or
Radical.
negative inside of a radical. I have neither of these, so that tells me I am continuous. What do I want to do to see whether or not I'm differentiable?
Find the
Find the derivative. So 4x cubed minus 8. So, what do you think? Is it differentiable?
Yes.
Yes, because I'm asking myself the same questions about the derivative. Is there anything in the denominator? Is there any negatives in the radical? No, so I'm good to go. So what does that mean has to be true?
MVT can be applied.
MVT can be applied, and what has to happen?
There has to be a spot where
There has to be a spot.
There has to be a spot where AROC equals IROC. So what do I want to find first? Because what I want to do is find that spot.
Let's find IROC.
You want to find IROC?
AROC.
Well, I can't find IROC yet because I don't know what to plug in. I'm trying to figure out what
You
to plug
said it
in.
would give us what to plug in.
It will. You are correct.
It will once you
When
find
you
it.
find F of 2 and F of 2.
There we go. We're gonna find AROC first. Yes. So I want f of b minus f of a over b minus a. So in this case, it's f of 2 minus f of 0 over 2 minus 0.
Because the interval is 13.
So if I plug in 2 to the 4th is 16, minus 2 times 8 is 16, so that gives me 0. I plug 0 in again, I'm also going to get 0. So we end up with 0.
You plug into the derivative or the original?
Wait, what did
The
you
original. I'm finding
plug
F.
in? 2 and 0.
I'm finding f, so I've got to plug in f. So that means my average rate of change from 0 to 2 of this function is 0.
Gotcha.
Okay? I need to figure out at what x value between 0 and 2 does the derivative equal that. So what do I want to do to find that?
The derivative equals 0.
Set the derivative equal to 0.
So if you'd have got like 1, would you set the derivative equal to 1?
Yes, if whatever my average rate of change is, that's what I want to set my derivative to.
What if can your average rate of change ever be 2 numbers?
Yeah, you
No.
the-
No radical.
No, you can only get one number out of your average rate of change. Okay, but you can get multiple x values for the c. So I'm move the 8 over.
For C?
Yes, you can get remember, because on that last graph, how many times did I hit 60?
5.
I hit 5 times. So that means that
C is where they equal.
C is where the instantaneous rate of change equals the average rate of change. Okay. So then I want to take the cube root. So what did I find right here in the cube root of 2?
That's when AROC equals I.
This is the value at which AROC equals the IROC, at which the instantaneous rate of change is the same as the average rate of change. So let's look at that on the graph.
So would that be our answer right there? That's
Yes, our answer, C equals the cube root of 2 would be the answer. So here is my function, f of 2, or f of x equals x to the 4th minus 8x. Okay, AROC is going to be when I connect 0 to 2. So at some point there has to be another spot where my tangent line is going to be the same. So we're going to show you that it is, that I've already got the dot in there, but let me see if I can, no, I'll just get it out of the way. So I'm going to go menu, I'm going to do trace, I'm going to do graph trace, I'm going to press enter, I'm going to press escape, and then I want to change this number. And I want to change it to what?
Cube root 2.
The cube root of 2. So I put that in there, I do the cube root, I move on the inside, and I get the cube root of 2. I press enter, and the cube root of 2 is right here. And if I draw a tangent line at the cube root of 2, what's it going to be?
Parallel to.
It's going to be parallel to my AROC, which is the secant line. Okay, so this is the point between 0 and 2 where the instantaneous rate of change equals the average rate of change. Okay, that is what the mean value theorem guarantees. Okay, and real quick, a real recap, how do we find instantaneous rate of change? Derivative plug in. How do I find average rate of change?
F of B minus F of A over minus A.
Okay, and then mean value theorem is when those two things equal, and I'm going to find the next value on my number.